Okay, what is an acid?
Below 7.
Right, so pH below 7, base pH greater than 7. Okay, let me do something neutral. pH is 7, right? So anything that's neutral, pH is 7. Anything is acidic, lower than 7. Anything that's basic, bigger than 7. Okay, as sour, base is bitter, right? Some of the example of acid is hydrochloric acid.
And base is like an antidote? Or like
Yes, and then base is like, for example, sodium,
is milk?
hydroxide.
Is milk also a base?
Yes, some of the milks are basic. Okay. So how do you know if something is basic or acid, right? We have a few definitions. ABL, right? ABL. A stands for Arrhenius. Base stands for Bronsted, Lowry. L stands for Lewis. Okay? So you need to memorize this chart. This is very important. It will definitely be in the test. The definition of acid and base. For Arrhenius, the acid is acid produced. This for acid. Where should I write it? Okay, acid is here, base is here.
Does it produce electrons?
No, it produce hydrogen ion. Okay, yes, for base it produce hydroxide. Bless you. Okay, so hydrogen ion is also the symbol of H+. Hydroxide is OH-. You need to remember that chemical formula. Hydrogen ion is H+, hydroxide ion is OH-. Okay, acid is positive, base is negative. Okay, remember that. Okay, Bronsted-Lowry, the acid definition is the same. Accept, change, produce to donate. So donate hydrogen ion. For base, it is the opposite of donating. It is receiving, right? So accept or receive. Accept hydrogen ion. For Lewis, is the opposite. So Lewis is Lewis dot structure, right? It's about electrons. So it's everything about electron for Lewis. So for Lewis, it is receive or accept. So it accepts electrons. For base, it donates electron. Okay, know that definition. Bronsted-Lowry donates hydrogen for acid, and then base Bronsted-Lowry receive or accept hydrogen ion. Sometimes they will also use the word proton. So remember that proton is just the same thing as hydrogen ion. Same thing, different name.
Wait, so for Lewis it accepts OH?
Lewis, no. Lewis, it accepts electron. Right? Lewis accepts.
Isn't like hydroxide the electron?
No, hydroxide is not electron.
Oh.
Yeah. But you can think of it that way as well. Correct.
Wait,
yeah, just stick to the definition. Lewis accepts electron, and then for base, it donates electron. So you can see that Bronsted-Lowry and Lewis are the opposite, right? For acid, it will be donating proton, but for base, it will be receiving proton. So B and the L are the opposite. Okay, so given an equation, you need to be able to identify which one is acid, which one is base, right? So for example, NH3 plus H2O becomes NH4 plus OH minus. Okay, here, who is the base, who is the acid? Okay, Daniel?
NH4 plus and the O is minus the base.
Nope. So how do you look at which one is acid, which one is base? So you always start from the left. You look at the left side, the reactant. You have two players, right?
Yeah.
NH3 or H2O. One of them is acid, one of them is base.
Oh.
So you have to look at who is donating, who is receiving.
So H2O is the base.
Okay, how do you know H2O is the base?
Because
H2O is donating, so H2O is
the
acid. So how do you know who is donating, who is receiving? So you look at before and after, right?
Yes,
to the left is before, to the left is after. How do I know to the left is before, to the right is after? Look at the arrow, right? Because arrow is telling you what's happening before and what's happening after the reaction. So the yellow, right, NH3, before it only has NH3. After, what happened to NH3? It becomes NH4. How did it become NH4? It accepts an H, right? Correct. So it accepts an H, that's why it has one more H. From H3 to H4. So NH3 receive an H. Plus. That's why it becomes H4 plus, right? Very obvious, right? NH3 plus H plus is NH4 plus. And then the green H2O becomes what? OH, right? So one H is missing. So it must be donating an H.
Yeah.
So you can write it down. NH3 receives an H plus. Therefore, NH3 is receive an H plus. It is base or acid?
It's going to be more acid.
No, base.
Base, sorry.
Right. You look at the definition. If you're confused with which one is acid or base, make a chart first. Write this chart down. Usually, the chart that will be most important, right? Which definition is the most important? This one. Brownster-Lurie is the most important one. Okay. Remember that acid donates H plus, base receive H plus. Okay. So here NH3 receive. So NH3 is base. And then H2O donates an H plus. Therefore, H2O is acid or base? Plus acid. Clear? Okay. So what if I flip the equations around? So what if I flip the equation to become NH4 plus OH minus becomes NH3 plus H2O. Okay, so you always start from left to right, unless the question tells you to go from right to left. Okay. So NH4 plus, what happened to NH4 plus? It becomes what? Yes. NH3, right? How did it become NH3? Donates an H. Very good. So it donates an H. So it donates H plus. So write it down. NH4 plus donates an H plus. Therefore, NH4 is acid or base? Acid. Okay. So you look at the OH as well. So OH becomes what? OH becomes H2O. How did it become H2O? It receives. Very good. So it receives H plus, right? So OH minus, not plus, OH minus receives an H plus. So therefore, OH minus is base. Okay. So far, so good. Okay. What if I flip the reaction? So I just change the arrow. Instead from left to right, I go from right to left, like this. So now you have to focus from the right to left, right? Okay, so from the opposite direction, so let's use green, okay. So NH3, from right to left, NH3 becomes what? NH4 plus. How did it become NH4 plus? It receives, right? It receives an H plus. So NH3 receives, if you wanted to use accept, that's fine, right? Most books will use accepts. It's the same thing. So accepts H plus, therefore NH3 is acid or base? Yeah, base, because it accepts. So focus on the H2O now. H2O goes to the left, becomes OH minus. How is it possible that H2O becomes OH? It donates or receives? Donates, right? So it donates H plus. So therefore, it's an acid. Okay. Okay.
So you just have to memorize the charge.
Yes, so you just need to memorize the charge. That's why the charge is important. Okay. The ABL definition. I mean, yes.
No, bro. Bro, that's 10. You're in a different. I was 30%.
Okay, so you label it, right? NH4 is acid. Let's use different color. Galaxy. So NH4 is acid. OH minus is base. Okay. And then NH3 is base.
NH3, oh yeah.
NH3 is base. H2O is acid. Okay. Last thing. Okay. The product, right? The product has to have a different name. You cannot have two acid or base at the same time in the equation like this. So what we do is that we just make it as conjugated base and conjugated acid. Okay. So it's just having a different name. So we know that which one is which. Conjugated acid or base is the product, is the base or acid formed after the reaction. Acid and base are reactants. So to the left, you have to look at the arrow, right? Because the arrow points from left to the right. So to the left has to be reactant, to the right is product. So we just put down the name conjugated to show that it is something that is formed as a result of a reaction. Okay, so I went over question 5 already. How to you have a few equations that you need to calculate, right? So pH equals to negative log of concentration of H, right? That's why it's called pH, right? So you have to look for H concentration. H stands for hydrogen, not hydroxide. If the question gives you hydroxide concentration, you have to calculate POH, right? Because OH is hydroxide. Okay, so remember these two equations. It will be given in the test. And last but not least, pH plus POH is, what's the magic number? pH plus POH? 14. 14, right? 14. So remember that. Okay, in an example, let's say the concentration of hydrogen ion is 10 to the negative 6, okay? So let's say concentration of hydrogen ion is 10 to the negative 6. What is POH then? So how do you calculate this? First, given H, you can find pH. So pH is negative log of 10 to the negative 6. Using your calculator, you find out that pH is 6. So you know that pH plus pOH is 14, pH is 6, go on. So pOH must be 8. Done. Okay. Okay. So we're clear with this one, right? Calculations. So the only problem with this is that whenever the question is given, right, you forgot to read the questions. You just simply plug it in. Pay attention to whether it's giving you hydroxide's concentration or hydrogen's concentration.
What is it given? Hydroxide?
Right, so if it's given hydroxide, right, you use POH. If it's given pH, you find H, right? So let's say in a situation like this, if a pH is, let's say a pH is 3, right? What is the concentration of hydroxide ion? Given pH is 3, what is the concentration of hydrogen ion? Okay, so if you already know pH is 3, what is pOH? 11, right? pOH is 11. Okay, so pOH is negative log of concentration of OH minus, which is the thing that you're looking for. So that is your variable X.
11, right?
Right? And pOH is 11. So you just plug it in. Let me highlight it. Right? pOH is 11. So you just plug pOH as 11. So 11 equals to negative log of OH minus. Hopefully Miss Nicastro already teach you how to do log very well, right? Minus both sides, right? Flip the base 10s over. So, okay, now I'm teaching you then. So OH minus is 10 to the power of negative 11. That's it. That's the answer.
Because the log cancels out.
Right? You do the log, right?
Is it always going to be whatever the...
Yeah, it's always going to be 10 to the power of what? Yeah. And because it's negative, so the power always is negative. Okay? And sometimes you're not going to get a beautiful number like this. You just plug into the calculator and see what number it will give it to you. I need that number, right? So don't forget to use your calculator. So we're done with pH and pOH. Next, you need to know what is the definition of neutralization, right? Neutralization, by definition, is when an acid and base reacts together to produce what? Something and something. Salt and water, correct? Salt and water, right? Because acid produce H plus, base produce OH minus. So the H and OH come together to become water. And then the remaining thing becomes salt. Okay, question can be given like this, right? So let's say I have sulfuric acid, H2SO4, react with NaOH, right? Sodium hydroxide. So what will it produce? It will produce salt and water, right? So water is H and OH. So you just cross out the H and OH. So what you have left is NaSO4. So the product that will produce is sodium sulfate. So the salt is sodium sulfate. Okay. Next, formula. Neutralizations and dilutions. They have the same formula. They are both M1V1 equals to M2V2. Okay. So for neutralization, MaVa is the same thing as MbVb, right? A stands for acid, B stands for base. Okay. So let's say given I have 5 molar of HCl and I have 50 milliliter and I need to neutralize it with 20 molar is kind of big, 2 molar of NaOH. What is the volume that I need in order to neutralize it? What do?
You just plug it in.
Plug it in, right? Yeah. So HCl is acid because there's an H over here. Sodium hydroxide is base because there's an OH over there. So you just plug it in. So this is acid, this is base. So acid is 5 times 50, right? Equals to 2 times X. So 5 times 50 equals to 2 times X. So X is 250 divided by 2 equals to 125 milliliter. Okay, so far so good. Okay, dilution is the same. So let's say I have 5 molar. Oh, I forgot to tell the formula for dilution. Dilution is MAVA equals to MBVB. This A stands for after dilution. This B stands for before dilution. Okay? So okay. So let's say the questions given is given that I have 10 milliliter of 5 molar of HCl. What is the volume of HCl I need if I wanted to dilute it to 1 molar?
1 molar.
Right?
So plug it in again.
So just plug it in, right? So this is before, right? Before the dilution. So now I need to dilute it. So that is the concentration after the dilution. So plug it in. So 10 times 5 equals to 1 times V, which is your volume after the dilution. So what is the volume after the dilution? So VA is 50 milliliter. Okay. However, the question will also ask, how much water do you need?
How much water do you need?
Yeah, that's how you dilute things, right? If you have a concentrated apple juice, how do you dilute it? You put more water, right? So the question will always ask, how much water would you need? You know that the final volume is 50. Initial volume is 10. So how much water do you need? Ruben?
How much water do you need?
Yeah, how much water do you need? If you know that before is 10, after is 50.
You need 40.
40. Yeah, right? 50 minus 40 is 50 minus 10 is 40. So this amount of water you need to add in. Okay. Last, strong acid or base versus weak acid or base. Okay. So you need to memorize the definition. A strong acid is an acid that will dissociate completely, 100%. Okay. A weak acid is an acid that will dissociate partially. So that is the definition.
Partially?
Yes, partially.
There's something different.
Okay. So the keyword is just completely or partially. The idea is this: if this is a strong acid and I have 100 of them, it means 100 of them will all donate hydrogen. They will all break down to give away hydrogen. But if it's a weak acid, right? If I have 100 of weak acid, maybe only 20 of them will give you hydrogen ion. The remaining 80 will not. That is the idea. Same thing for base, right? If it's a strong base, it will give out 100% of hydroxide ion. If it's weak base, it will only partially give you hydrogen ion, hydroxide ion. Yeah, like 50, 40. As long as it's not 100%, it will be weak. As long as it's 100%, it will be strong, right? So you can also say that as a stronger or weaker, right? A stronger acid is an acid that can give out more, right? More percentage of hydrogen. A weaker acid is something that can give out less amount of hydroxide or a hydrogen ion, sorry. So it's about percentage. With that, we're done with acid and base. We'll go over energy tomorrow. So far, any question? Any question? Acid and base. Molar calculation.
Can you scroll up for a second? Can you scroll up? Actually, I have a question. Wait, actually, go down a little bit. Actually, no, right there. MAPA. Wait, why did you do it? Why did you not do M1? What's M1, D1? Same thing.
The same thing. 1 and 2 is just a symbol.
Okay.
Right. So I'm making you easier, letting you know that 1 is acid, 2 is base.
Okay.
So use A, B as a representation instead of 1 or 2. Any other question?
No. That was
No?
my question.
Okay. So we can pause.